Arithmetic. What's the pattern? No. What's the pattern in general for an arithmetic sequence? What's going on as you jumpity jump, jump, jump? Addition or subtraction of a constant, a single constant. Okay? So, someone who thinks they know what A1 is, don't tell me what it is yet. Let me know how you did the problem. You see the fourth term is 7 and the seventh term is -5. Someone that thinks they know the first term. What observation did you make? Jacob?
Well, I saw that 7 and 4 are 3/6 apart.
Uh-huh.
I found the difference between 7 and -5. And then I did that by 3 to get a common 4.
Now let's see if that made sense. So he figured out what the difference was between the two that were far away, -12. He said, wait a minute, that had to be split up between 1, 2. Was he right dividing it by 3?
Yes.
Because there were 3 jumps. Each of the 3 jumps would add D, add D, add D, so add 3D. So you could have thought that his formula, in a sense, was 7 plus 3D is equal to -5. That's ultimately what was going on. It's kind of using the idea of the nth term formula by saying, like, hey, you start at 7, you take 3 jumps of D, and you need to land at -5. Ultimately, subtract the 7, divide by 3. This is kind of what he's solving just using logic. And then, can someone else use that logic, or maybe you figured out something super similar, how can you now go backwards to not just a sub 3 or a sub 2, but a sub 1, because that's what we're supposed to be finding. Is anybody able to follow that logic backwards? You're going to add 4? How come? Because if you go this way, what are you doing? Subtracting. So if you go backwards, you have to add. So then you could just add 4 every time and say, well, that's going to be 11, that's going to be 15, this one's going to be a sub 1. Now that was the logical way. Does it work? We could try it, but 19 minus 4, minus 4, minus 4, minus 4, that'd be 3. Minus 4, -1, minus 4, -5. Perfect. However, there is a formula way of doing it. Did anybody try to use a sub n?
I tried.
It gets a little confusing. Some of you hopefully at least were looking in your notes and you saw a sub n. A sub n says take the first term and add n minus 1 jumps of D. You could have taken this formula and said, all right, I know a sub 4. A sub 4 is equal to 7, which must be the first term plus 4 minus 1 times D. Just by looking at the fourth term, I don't know the first term and I don't know D, but I do know that n is 4. So we could have plugged this in. You could actually even solve if you wanted. And you would end up with, let's see, 7 is equal to a sub 1 plus 4D. Oh, no, just be silly. Plus 3D. I don't know why that was so hard in my head. Then I could also take a sub 7. I could make a little formula from him and say, well, I know a sub 7 is -5, which has to be a sub 1 plus 5 minus 1D. Exactly. It's a little baby system. Well, the logic way does work, and I think it's easier. But you could have, some of you like formulas and like just following formulas. You could have plugged into the formula twice. Then you would have had a little baby system of equations. And if you wanted to be super snazzy, I guess you could have done like elimination with these two by multiplying this one by a -1. And if you multiply it by a negative, every sign flips. And just looking at the red, 7 plus 5 would be 12. A sub 1 minus a sub 1 would cancel. 3D minus 4D.
7. Yeah, 70. Right? Oh, negative. -D.
No, that's okay. I'm second guessing my work. A sub 4, a sub 7. You guys see the silly mistake I made? There's one silly mistake. I wrote -5 as the 7th term. What did I write as n for the 7th term? Oh, I was stealing the 5. Where should this n have come from? Ah, there we go. There's the mistake. Seven minus 1 would be 60. And what's 3d minus 60? D is equal to -4. And once you found -4, couldn't we plug that back in and say, okay, 3 times -4 is 12. 12 plus 7 is 19. We could have back substituted and figured out that a sub 1 is 19. Very different method, but still works too. So the formula would work. You would have to do a little baby system of equations. Kiddos, this is an example that we skipped on Friday because we weren't able to do as many homework helps as I would have liked because time just didn't permit. But this is probably the trickiest arithmetic nth term type example that you'll see. They don't give you the first, they don't give you the D, and you kind of have to do a little bit of a discovery, a little bit of an exploration to find it. Noah, what's up, bud?
The way that you did it, would that always work?
Yeah. As long as it's an arithmetic one, to where you know that the pattern is plus D plus D plus D. He was able just to figure out the jumps and solve. That was okay. Okay, there was another formula that we saw, though. Let's go ahead and go back into our notes. There's another formula that we saw. Even though our backboard does say section 9.3, we're not entirely covering section 9.3. We're really just starting it because our job today is not just to start 9.3, but also to finish first 9.2. So I did have you guys fully attempting homework for today. Some of you took the time over the weekend to try to dig a little bit deeper into this section and learn a little bit on your own. Hey, lady. Okay. Okay, thank you for letting me know. We just did a warm-up problem, which was kind of like a tricky homework help, but now we're still in section 9.2. Okay, so section 9.2, we saw this formula on Friday, and you guys were writing it down on Friday, but I didn't get to introduce where this came from. I'm just going to tell you the story really, really fast about this guy named Gauss. He was actually, he did a lot of discoveries just kind of in the STEM field in general without going too specific. But Gauss, he was a brilliant guy, but he used to be a kid. The story goes, and imagine it was a while ago, a few hundred years, probably, so the classrooms are very different than they are today. But the story goes that little Gauss was in some little elementary classroom, probably more like a one-room schoolroom sort of thing. And the entire class was being really rowdy. Poor little teacher was just like, I am so done with these kids. Then you needed a break. And everyone grab out your slates, because that's all they probably had to write on. All the numbers to 100. You can't come up to my desk. You can't do anything. Just take a little bit of time. It should, right? To add together all the numbers. Settled, sits down, thinks that she'll have at least a little bit, probably was a he, a little bit of time. All of a sudden, he brings his slate up and he has an 50-50. Probably he thought that they would have more time before the kids finished. And how did little Gauss do 50-50 so fast? And just all the numbers.
The first number to the last number, and then multiply it by half of the amount of numbers. By 100 by 2, and then you multiply 101 by 2. How did you get that from? Why is that
What's 1 plus 100? What's 2 plus 99? What's 3 plus 98? Do you see a pattern? For any arithmetic sequence, this one's arithmetic because you just add 1 every time. Arithmetic, adding 3 every time, or -5 every time. If you know the last number, which sometimes is really hard to find, and sometimes you have to use a If you know the last number, you can add the first and last, find what it's going to be every single time you add and say, wait, 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 but it takes a pair of numbers to make that sum. Well, a pair of numbers, I'm going to have to count how many numbers there are and divide it by 2 and then multiply. So if you guys take, how many numbers 1 to 100? 50. Sorry, 100, cut that in half. 50, there will be 50 sets of 101. So one. It's done. Yeah, he was a little one. He was quick. He was a quick little whippersnapper. Anyway, so that's how the story goes. I'm not totally able, I wasn't there. Can't tell you exactly how it happened. But that's how the story goes. This is, however, this pattern can be true for any arithmetic series. So therefore, you guys wrote down that formula hopefully on Friday. Let's go ahead and zoom in on a couple examples just so that your notes do have some examples of us using this formula as we finish 9.2. So guys, think about what you have here. It's a sum of, well, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different digits. So this would be the sum. Let's see, S sub 10, right? The sum of the first 10 terms. The 10th partial sum. I'm trying to find S sub 10. Yes, you could do 1 plus 3, and then that plus 5, and then that plus 7. Or you could just say, wait a minute, hold on, I see a pattern. And the pattern is, first of all, it is arithmetic, because you're adding 2 every time. So then we know we're allowed to use the following pattern. And the following pattern, what's 1 plus 19? What's 3 plus 17? What's, okay, we're going to have how many sets of 20? 10. Not 10. Why only 5? Every pairing needs 2. So there are 10 total. 10 divided by 2, which is 5. What's going to be the sum when you're done? You could wow some pretty little kids with that. Maybe some adults too. Yeah. Oh, the 20 was from, here's what my formula would have said. Would have said there are 10 terms divided by 2, so n over 2, times a sub 1 plus a sub n. So that's how I got the 20, is I added 1 plus 19. But remember, this is the formula I'm trying to use. And guys, why was I using a sub 10 in this example? Yeah, the first 10 numbers is the sum I was trying to find, Joel.
So can you only use that formula if there's an even amount of numbers?
No, actually it works for odd as well, ironically enough, because then in the very middle of your series is going to be half of the sum, if that makes sense. Yeah. Okay, so then what would you guys do for this one when they don't tell you the entire series? They just tell you, find S sub 10. You know a sub 1 is 4, and you know the common difference, the jumpity jump jump is 7. I mean, could we start making a series if we really wanted to? Yeah, but then we'd have to go all the way to the 10th term. Maybe we can shortcut the process. But some of you are like, I wish I saw the whole thing. I know, you could write it out if you want. But yeah, some of you are starting to plug in for me. Let me go ahead and write the formula since we don't all have it memorized. Okay, so what am I doing for S sub 10? Good, 10 over 2. So just like the one up above, there's going to be 5 pairings of, okay, we know a sub 1, that's, what don't we know? The last, because they didn't give us the entire series. If we knew the last, it'd be as easy as that one, just add the first and last, but since we don't have it, okay, it's all right, we're not totally stuck, we just have to do a little more work. Could we do plus 7 plus 7 plus 7 plus 7 10th? Yes, but is there a formula to jump to? Because couldn't they be asking for the 50th sum? We wouldn't jump to the 50th term, hopefully. How do we jump to the 10th term? Add 7, but how many 7s to the a sub 1 or to the 4? Ooh, not 6. Whoa, whoa. I was copying. It is 1 fewer than, but it's 1 fewer than, where are we trying to get to? The 10th. So it's going to be 9 jumps of 7. Does that make sense? We're not decreasing the common difference by 1. We're decreasing the jumps by 1. So remember, This is your a sub 1 plus n minus 1, 10 minus 1, times your common difference d. So 4 plus 9 jumps of 7, 4 plus 63, 7. So now that I've gotten there without having to jumpity jump, jump, jump all the way, I can say, oh, this sum is just going to be 5 pairings of 4 plus 67, 71, which will be 355. Nice. Jacob.
So why don't we multiply by 10? Why don't we multiply by 9?
Think of it this way. We're starting at a first, trying to get to, for instance, like a fifth. How many jumps to get there? 1, 2, 3, 4. You have 5 fingers, but only 4 spaces. So it's always going to be one fewer jump. And if you look at sequences, we looked at this on Friday. If you look at sequences, to get, for instance, from 1 to 9, from the first term to the fifth term, you'll need to do 1, 2, 3, 4 additions. Does that make sense? Yeah, so that's going to be one fewer. And that's why the formula says a sub n is equal to a sub 1 plus n minus 1 times d. All right, kiddos. Let's go ahead and save the word problems in case you get stuck on any of the homework ones. Sound good? Let's go ahead and skip ahead to 9.3 so we can start it. I know some of you guys started homework over the weekend on 9.2, so I'll see if you have any questions in just a little bit. But let's get into 9.3 first. This is the non-calculator part. Yeah, you have to show your work on these ones. This part of the test, which, to be honest, since it's chapel schedule, I might have you take it in parts, but this one's the calculator part. Yeah. So this is why it says just show all your work. Okay? Now, there is another way to solve. There's lots of ways of solving this. All right, if you guys notice, we are now in section 9.3, which still sequences, still series, still a sub 1, a sub 2, a sub 3, a sub 4, but the pattern is different. Do you guys remember for arithmetic how I tried to simplify how the pattern was written? Do you remember that? And even though there was this whole like a sub 2 minus a sub 1 and a sub 3 minus a sub 2 equals d, I said it's easier, I thought, to look at the jumpity jump jump as plus d, but in this one, it's not going to be plus. The ratio, division finds me the common ratio. Division finds it for me, but remember common difference? Subtraction found me the common difference. The division finds what was multiplied. The division finds what was multiplied. So the jumpity jump jump is times r times the common ratio. So the common ratio is r, which we can find by dividing. So example, if I was to give you something like, I'm pretty sure we have some on the other page, but as you guys are writing, let's do minus 6 Why is this a geometric series? Uh-oh, I just made this a lot harder than it needed to be. That's okay. I think you guys can do it because we did additions in the other one. Lainey. Good. In this series, r is equal to -3. Now, this is, remember, this would just be a little different in that it wouldn't be written with additions and subtractions. It would be written as 2, then -6, then +18, 54. Series has additions or subtractions in between. Sequences have just commas. But how did Lainey know it was a -3 and not just a normal 3? The signs. Remember that snazzy word for it, though? Alternating, like an alternator, right? Alternating. Okay, you guys have this box down? Yes. The most important part, geometric, times r, times r, times r, times r, common ratio. So, do you need me to dual page it? Just a couple of you guys were still writing. Here we go. There is a formula, and we're going to do the formula. We're going to write down the formula. We're going to memorize the formula, but let's see if we can understand where the formula comes from. Oh, it's a little screen shade. Poor little guy. Anyway, coming back. If I wanted to find the 10th term without jumping, which we could because there are already 5 here. Wait. As you guys write it down, what's the pattern? By 2 over and over and over. Geometric. If you're multiplying by the same number over and over and over. R is equal to times 2. Think about what we did with arithmetic sequences, which we talked about just a second ago about the pattern. And how would that work for geometric? If I told you we had to start at 3. Ooh, why'd I put times and not plus? Because we're multiplying now. For arithmetic, we were adding, so it would be 3 plus repeated jumps of addition. But now I'm doing 3 times repeated jumps of multiplication. How many jumps of multiplying 2 do you think we're going to do to get to the 10th term from the first term? Does that make sense? Okay, 9 jumps. But wait a minute. How do you write times 2 times 2 times 2 9 times quickly? Not squared, but you have the right idea. 2 to the... Use exponents. Does it make sense why the formula is what it is? The nth term, you start with the first term. And you do n minus 1 jumps of multiplication of your common ratio. If you add and add, if you add 2, add 2, add 2, add 2, that would be n minus 1 times 2. Repeated addition is multiplication, but repeated multiplication are exponents. But the pattern is super, super similar. And that's why these two are so special, is because their formulas are so nice and so logical in the sense of, oh, you're starting with a first term and then you're making repeated jumps of the exact same pattern. Just instead of arithmetic, you're not adding 9 times 2. You're multiplying 2 to the power of 9. Does that kind of make sense? If you're a highlighting, starring kind of person, also an important formula to have memorized. Also an important formula to have memorized. Remember, we are splitting up Chapter 9 into 2 pieces. Sections 9.1 through 9.5, but here's the good news. We're skipping 9.4. So 9.1, 9.2, 9.3, which we're covering 9.3 right now. And then 9.5. Then we're going to have a test with, what did I say, 75 points, right? Because it's the majority of Chapter 9. Then we'll cover 9.6 and 9.7, all about probability, and have a probability quiz worth 25 points. Put it all together, and there it is. Your calendar's all up to date. I think your 9.5 quest test worth 75 points is pretty much right after break. We have like a Monday to regroup, answer any questions, and then we'll have that test on Tuesday. Which you might be like, that's awful. But it gives you plenty of time to formula card it and make sure the formulas are done. Formula card it like Quizlet, like make formula cards and memorize. Flashcard it. You guys have taken enough language classes to know what I'm talking about. Okay. No formula. Okay. All right, but this is an important one to also be memorizing. Here we go. So guys, how do I find the 12th term of the geometric sequence? I guess. I mean, well, first of all, we can't go to 12 if we don't know a pattern anyway. So what's the pattern? Divided by 4. Wait. So what's my common ratio? Divide by 4? That's awkward. Good. R equals 1/4 because, remember, division is multiplication of the reciprocal, right? So divided by 4 would be times 1/4, times 1/4, etc., etc., etc. Okay, so could you in your calculator do divide by 4, divide by 4, divide by 4, divide by 4? Wait, how many have I done? I need to get to 12, which means I need to do 11 of them. Wait, why don't we just use our math logic to get there? We need to get to the 12th term, starting from the first term and doing how many jumps? 11, 12 minus 1 of 1/4. The formula is super logical, but some of you definitely just need to memorize it and use it. That's just how your brains work. But we're doing 11 jumps of times 1/4 times 1/4 times 1. Don't do it over and over and lose count. Just use an exponent. Oh, it's a multiplication. A raised dot. Good catch. Thanks for letting me know that that was not apparent to all. Can someone get me an answer? It's really, really tiny if you think about it. Divide by 4, divide by 4, divide by 4, divide by 4. Ooh. 2.2, Chris? Which would be the same, as you guys know scientific notation, right? Move it 5 times, which would be zeros. 1, 2, 3, 4. Oh, 2.3. Thank you. We don't have to worry about significant figures per se because I'm pretty lenient on you guys as far as rounding. Math, when you're given numbers, is not quite the same as like in science when you're given measurements and it's been measured to a certain accuracy, right? And so you need to maintain that accuracy. In math, you're just being given numbers, so it's like, okay, I could go on forever with the decimal. In all reality, I probably only need like 6 decimal places. That's like the most practical in most applications. So 1, 2, 3, 4, 5, 6. We're good. Guys, remember the homework help that we started in our workspace this morning? It was a little harder. Let's check it. Is this a homework help maybe a little harder? What's similar between this example and the one we started class with? Yeah, it gives us 2 random terms. But can we try to, how many of you guys like Jacob's idea? Like the pattern, puzzle, logic? Okay, so let's try to use it. If you didn't like that, you can try to use the pattern that I was saying, which was the formula way. And you could actually plug in and say, hey, a sub 2 is equal to 3, which is equal to formula. A sub 5 is equal to 3 over 64, which is equal to formula. Then use a system of equations to solve. But hold on. If you like Jacob's way, let's try it. Let's try the logic pattern finding way instead. So, Jacob, you're not allowed to talk, but you can be thinking about how your method would go. Someone else, try to use the idea of jumpity jump jumps. What do we see? What do we have? Okay, Jaden up here is saying and noticing that between a sub 2 and a sub 5, he was like divide by 3. Why is he thinking 3? Because how many jumps are there to get from the 2nd to the 5th? Now here's the dilemma. Why am I going to be like, ooh, good idea with the 3, bad idea with the division? It's geometric. Division would have been the way for arithmetic because you would have had 3 jumps, 3 times d, so divide by 3. The problem is this one, it's not 3 times d, it's times r cubed. Yeah. R is 1/8. Close. I need 3 jumps. Yours was 2. So if it was only 2 jumps, it would be 1/8. Since it's 3 jumps, it's actually going to be 1/4. But how did I figure that out? think of Jacob's way of taking the latter and subtracting the earlier, but now we're not subtracting, we're dividing. So what's 3 over 64 divided by 3? I know you guys don't like this. You could use my little trick and say, oh, this is 3 over 3 times 64. Or if you like it a little bit better, you could multiply by the reciprocal. Make the 3 over 1. So 3 over 64 times 1/3. The 3's reduce. You end up with 1 over 64. So the total that was multiplied, and you guys can probably see that, wasn't it multiplied by 1 over 64? But 1 over 64 needs to equal how many r's? R cubed. And how do we get rid of a cubed? We cube root it. So if you cube root the r, you got to cube root the 1 over 64. What times what is 64? 4 is. Now how does that help? What are we trying to find? It's weird because of how the problem is stated, but look up there. Doesn't it say first term? Okay, so if we're trying to find the first term, and if we know that r is equal to 1/4, guys, to go backwards in arithmetic, we subtract instead of add, or add instead of subtract. But in order to go backwards in geometric, instead of multiplying, we're going to divide. So think, instead of multiplying by 1/4, we're going to divide by 1/4, which would be the same thing as multiplying by 4, which means my first term must be 12. Now, would it have worked? Would it have worked to solve this way? And the answer is yes. But instead of doing elimination, which would be kind of nasty, it might be easier to do a little bit of substitution where you solve first. Then you could have plugged in. And then if you had kept simplifying, you would have gotten 3 over 64 is equal to 3r squared. Oh, what didn't I do? What's my formula say about the power, though? Minus 1. This would be r to the 1, which makes everything just a little bit better. Because what's r to the 1 and r to the 4th going to reduce to be? Good, there we go. R to the 1, R to the 1. And so actually end up, if you guys notice, dividing the 3 and then cube rooting, and we end up at the exact same place. And then we could have backslid to go ahead and solve. I like the jumpity jump way. I think it's faster, but you have to get the logic down of how a sequence progresses. Does that kind of make sense? Okay, we didn't get to go over questions on your 9.2, but we did get to do some homework help. So go ahead and finish up that 9.2 if you haven't yet. 9.3 we will finish in notes tomorrow for that homework due Wednesday. Sound good? We're all on the same page? All right, bye guys. See you later. See ya. So Lainey came in.